Okay, we are on the second page of this guy here. We want to evaluate these limits, and the first one is x goes to 8 of this whole nastiness here. So I'm not going to write it again, you can see it. First thing you should do, always, 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 when you're trying to solve a limit, is plug in wherever x is headed. So we plug in 8, and we just happen to get, shocker of the week here, 0 over, you plug in 8 here, you get 64 minus 16 times 8, what's that? 128 plus 64, so 0 over 0. Alright, now, I told you, if you plug in 8 and you get 0, x minus 8 has to factor out of here. X minus 8 is the top, so that's already factored out. But this bottom has to factor out an x minus 8. So you're going to do limit x goes to 8 of x minus 8, and you're just going to factor the bottom. It's a quadratic equation, so we know we can factor it. And it happens to be x minus 8 times x minus 8. So lucky for us, one of those x minus 8s cancel out. And we end up with limit x goes to 8 of 1 over x minus 8. Now we try to plug in again, and oh no, 1 over 0. Well, this is not the same thing as 0 over 0. 0 over 0 is indeterminate. You don't know what's going on. You have to do more work. Over here, this is 1 over 0. This is a vertical asymptote, a VA. There you go. Vertical asymptote. Now all we need to do is figure out, again, is if you got a graph here, we've got an asymptote at 8. We know that. So here's 8. Here's our asymptote. Does the graph go like this? Then the answer is infinity, right? Does it go like this? Hey there. Does it go like this? What is happening? Does it go like this? Then the answer is does not exist. And if both of them go down, then the answer is negative infinity. So we got to check this out. Now, here's all I'm saying. I've said this a bunch of times in class. If you plug in numbers super close to 8, it should be headed to infinity, and if they're positive, then it's headed to positive infinity. If the numbers you're plugging in, if the numbers you're plugging in around 8 and you're getting negative answers back, then it's headed to negative infinity. So all I say, this is just a visualization. Draw a little number line, there's 8. We're going to think about numbers super close to 8 on the left-hand side, so down here somewhere. I'm talking about like 7.9999999, so many nines, you're just tired of saying it. And when you plug that in, you're going to get a very small number on the bottom, but it's going to be a negative number, a very small negative number. And 1 divided by a very small negative number is a gigantic negative number, but this is going to negative infinity on the side. When you plug in a number on the right-hand side, a number larger than 8, the bottom is going to be still a very small number, but positive now, because x is bigger than 8, which means 1 over that number is positive, and the graph is going to end up looking like this. Here's your asymptote at 8. And we're going to have a negative 1 going to here, and then this one's going to look like that. So the answer is does not exist. And it doesn't exist because the two sides go in different directions. They're not going to meet. What just happened there? Get rid of all this junk. That wasn't good. Oh, I see. I'm not really sure if I like this whole setup here. Cut. This is the dumbest thing in the world. Just erase that stuff. What's going on here? You. Goodbye. That is so dumb. I'm really upset with you, Scribbler. Alright, let's do this. This is absolutely ridiculous. I'm glad you're watching the video. You can hear me argue with my computer. Alright, get out of here. So great. My god. Technical difficulties. Alright, let's do this. Alright. B, you're gonna plug in 0 and you're gonna get sine of 0, which is 0 over 0. Oh my, 0 over 0. Well, now normally I would tell you to factor this, try to get some stuff going on, but you got trig, and you really don't like trig. But if you do see a sign up top and x is on the bottom, probably we're going to end up using this rule, which says if x goes to 0, of sine x over x. That's going to equal 1. That's just a rule we learned before. We can prove it. We didn't prove it, but we can. You can also check it out using like a table. As x gets super close to 0, this thing is like 0.999999, super close to 1. But anyway, we need to somehow get this fraction out of this fraction. And what we can do, we got the 8 in there. That's not really a problem. We can factor an x out of the bottom. So that's going to leave us with this. The limit x is going to 0 of sine of 8x over x. We factored out that x. And I'm going to separate the fractions, because multiplying fractions is the same thing as just multiplying across the tops and the bottoms. If you factor an x out of that bottom, you're going to be left with an x minus secant of x. Okay, so we've got the limit x is going to 0 of really these two fractions being multiplied. Okay, now when you plug 0 into this sine 8x over x, you're going to get 0 over 0 again. But when you plug 0 into this second fraction, you get, just do this, you get 1 over 0 minus secant of 0. And secant of 0, we all remember, is 1. And this fraction is not going to equal 0. So the only problem is this fraction over here. Now, as long as what's in the parentheses is the same exact thing as what's outside, or one on the bottom, so x up here, x on the bottom, we have 8x here. We just need 8x down here, so I'm just going to put an 8 there. No problem. But that does change the expression here, which means I have to undo what I've done, and to do that I'm just going to put an 8 up top here. Okay, so now limit x goes to 0, this fraction sine of 8x over 8x is going to turn into 1. But there's that 8 out front, and we're multiplying it by this second fraction. So it's 8 times negative 1, and the answer is negative 8. Congratulations, you're done. Oh my god, what kind of nonsense is this? Get out of here, nobody likes you. Alright, good. Down here, C. You plug it in 0, you're going to get 2 over 0. That is not 0 over 0. 2 over 0 means, say it with me now, asymptote. Woo, asymptote. Okay, so you plug in 0 and you get 2 over 0. There's an asymptote there. We're going to check both sides of 0. So if x is super close to 0, but on the left-hand side here, so we're plugging in a very small negative number. Well, 2 plus x, which x is a very small negative number, 2 plus a small negative number is still a positive number, right? So on this side, we've got a positive on the top, divided by. If we plug in a super small number that's negative, well, squaring it makes a positive, so that's a positive, times a very small negative number minus 4 is also going to be negative, so negative. So we have a positive divided by a positive times a negative. Well, that's a negative. So the left-hand side at 0 is going down to negative infinity. Now we'll check the right-hand side. We're going to plug in a very, very tiny positive number. Well, the top is still 2 plus a positive number. That's positive. The bottom is that positive number squared. That's positive. Times that positive number minus 4. But it's a very small positive number, so minus 4 makes it negative. And both of these are negative. And since they are both the same sign, that means they're both going in the same direction. And the answer over here is not this, is negative infinity. Okay. That was easy. It's good when you don't get 0 over 0 because you don't have to do more work. And nobody likes more work. Okay. Limit x goes to 5. You plug it in. We're going to get 0 over 0. Which means we got to do some work here. So limit x is going to 5. Let's make this a little better. Of root x minus root 5 over, that's my 5s are terrible, I apologize, over x minus 5. If you get 0 over 0, x minus 5 has to cancel out, we know that. And you see square roots, so you're going to multiply by the conjugate. This one's a gimme by this point. Root x plus root 5. There we go. We are so smart. Multiplying conjugates up top is going to leave us with just x minus 5. And on the bottom, we're not going to multiply it out. We're going to have x minus 5 times root x plus root 5. The x minus 5s are going to cancel out, leaving a 1 on top. And now when I plug in 5, I get 1 over root 5 plus root 5, which is 1 over 2 root 5. There you go. Nicely done. Okay. There we go. Let's get rid of this. What now? This guy. Now when we plug in 0 here, we get 0 over 0 minus 9, which is 0 over negative 9, which is just 0. That's just a bad trick on my part. We just get 0. Nothing big there. Over here, I don't know why I have so many of these on this one test. When you plug in 1, you get the cubed root of 1, which is 1, plus 1, which is 2, over 1 minus 1, which is 0, which means there's an asymptote happening here. We'll do the same thing we did for the last few. Check 1, and we'll check numbers to the left of 1. So numbers super close to 1. Well, a number super close to 1, cubed root of that is still positive, plus 1, so that's positive. So the top is positive on the side. And when you plug in a number super close to 1 but smaller, you're going to get negative on the bottom, so negative. When you plug in a number close to 1 but on the right-hand side up here, top is still positive, and now the bottom is positive as well. Because a number bigger than 1, minus 1, is a positive number. Which means this limit does not exist. So, even though that's what you write first, the real answer is does not exist. Alright, G. Anytime you see this, x going to infinity, all they want is the horizontal asymptote. And if you remember your horizontal asymptote rules, you take the leading coefficient of the numerator and divide it, you find the degree of the numerator and the degree of the denominator. If they are the same, which they are, see, I tried to trick you here a little bit. I put the x cubes out front, very sneaky, but really x to the 10th is the degree. 10 is the degree. So 4x to the 10th should be the leading term. I just didn't write it out there. And 8x to the 10th would be the leading term on the bottom. Since they have the same degree, the answer is just the coefficient fraction, which is 4 over 8, which is 1/2. That's the horizontal asymptote, and they want the horizontal asymptote because they're saying x is going to infinity. Okay. And h, limit x goes to infinity of 5 minus e to the x. There's really not much work to do here. If x is going to infinity, you just got to imagine x is becoming a gigantic number, something really, 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 really big, and just getting bigger and bigger and bigger. If you plug in e to a gigantic number, well, e to a gigantic number is another gigantic, an even bigger number, gigantic-er, if you will. So 5 minus a huge number that's just getting bigger as x goes to infinity is just going to go to negative infinity. Okay, that was fun.